Right. So this discussion is going to be recorded. Right.
Yes.
Because this discussion is going to be recorded, then you'll have access to the recording during your own leisure.
Yes,
Right.
yes.
So there are a couple of things, obviously, that you need to learn here. And first things first, you need to learn differentiation. Right. The
Yes.
first principles have been put on the screen. And it's very important that you're able to do derivatives very, very comfortably. And
Yes, yes.
we're gonna look together at a couple of problems where, sorry, we're not gonna waste a lot of time in terms of covering the basics, but we are gonna sit on the kinds of things that you need to know for the exam.
Yes,
Right.
yes.
And what are the things that you need to know for the exam? In terms of differentiation, because your exam paper is on that, you must be in a position to perform derivatives using notions of what you call the chain rule and multiple other rules. Okay, let's give
Y-
some examples. Right. I'm going to give some examples of derivatives like number one. Okay, we are saying, in other words, the question is find dy dx. Right, in number one, you're given y equals the square root of sine 2x.
Yes.
The ln of the natural log of the square root of 1 plus 3x. Okay, let's look at these examples and we look at the solutions to these. Right, the approximate starting time now is about 1910.
Yes.
All right, you must be here for like 2 hours. We shall solve a lot of questions together. Okay, just to make sure that you're better prepared. But first, we must just understand differentiation, then move to integration and other chapters. Right,
Yes,
now,
yes.
for example, given y equals the square root of the sine of 2x, these can also be written as the sine of 2x to the power 1/2, like so.
Yes.
Right, so if we agree that it can be written as the sine of 2x to the power 1/2, what is the derivative in terms of dy dx of this? Right, so you bring down the 1/2 and
Yeah.
you keep the inside the same. You subtract 1 from the 1/2, getting 1/2
Minus one
minus
and a
1
half.
is
Yep.
minus 1/2. You multiply by the derivative of the inside, like so.
Yes.
So that if you have dy dx is 1/2 the sine of 2x to minus 1/2, the derivative of sine is what? Is cosine.
Yes, cosine. Sorry, yeah.
Yeah, it's cosine of 2x, and we multiply, therefore, by the derivative of 2x.
Yes.
Right, so that in the end, what we're getting is 1/2 times the sine of 2x to minus 1/2, the cosine of 2x times 2. And this is the answer.
Yes.
Right, this is the answer, and this answer can be written differently, or it can be written in many forms, because you can write it as dy dx. Now, the fact that here you have a negative power means that you can write it as 1/2 1 over the square root of the
Yes.
sine of 2x. Then you have 2 cosine 2x. And write it as 2 cosine 2x. Now the 2 cancels, giving us dy dx is the same as the cosine of 2x divided by the trigonometric sign
yes.
of 2x. Like so. So this is the answer to this question. Right, so this brings us to some basic rules that we need to learn. For example, we need to recap on the multiple rules that pertain differentiation. So it's very important to revise together the basic rules of differentiation. Let's look at some revision. Right, this lesson is being recorded, so you'll have access to this recording. So f of x equals x to the power n implies that f primed. Okay, if f of x is x to the power n, what is the derivative of this function? Is nx to the n minus 1.
Yes.
Right, so there's another function we can call g, such that if you have f of x to the nth power, then what is g primed of x? Is n f of x to the n minus 1 times f primed of x. Right, so this one is called the chain rule.
Yes.
Right, so there are a couple of rules we need to learn, like sometimes they become tricky in the exam, and we're going to look at some of these problems. All right, if they give you a number to the power f of x, what is the meaning of this? What is the derivative of this? Okay, let's write it properly. Somebody gives us a function f of x. It is a number to the power g of x. What is f prime of x under this condition? Right, so f primed of x is going to be the same as what? It's going to be the same as g primed of x. It's going to be exactly g primed of x multiplied by a to the power g of x times the ln of g of x. So if you have a number to the power g of x, the derivative of that is g primed times exactly the same expression times the natural log ln of g of x. Next point. G of x equals e to the power f of x. Okay, if you're given e to the power f, what is g primed of x? Okay, this is the base of the natural log. And therefore, the derivative of g becomes the same thing. But
Yes. Stays the
what
same.
you have is you simply multiply by the derivative of the function. Okay, this is some brief revision. I'm just recapping on some of the basic rules, and then we shall go straight to lots of exam questions. Now, there is another rule that says there's a function g. Hello?
Yes, I'm here.
All right, my dear. All right, just 1 minute. Okay, yeah, I'll take it from the oven, my dear. Oven, please. Okay, thank you, my dear. Right, okay. Right, so we have g of x, which equals the natural log of f of x. Okay, if g of x is the natural log of f of x, what is the derivative of this? The derivative of these becomes what? Okay, if this is the case, to find the derivative, you say 1 over f of x times f primed of x. Right, so in other words, if you have the natural log of a function, it's 1 over the function times the derivative of the function. What about if there's a function, so these are like separate. There is a function g, and you have the log of f base a. Then what is the derivative of this? Like the log of f of f of x base 3. What is the derivative? Which is 1 over the natural log f primed divided by f of x. Like this. Okay, what about if there's a function g of x and it is the same as the sine of f of x? Then the derivative of g, okay, the derivative of the sine is cosine, but you then multiply by the derivative of the argument of the function, and you have cosine f of x. There is a function y. If you have cosine of f of x, what is the derivative of these in view of dy dx of this? So this is minus the sine. Okay, the derivative of cosine is what? Is minus the sine. Right, but you multiply by the derivative of the argument. So it's minus the sine. So you put a minus, but you multiply by the derivative of the f, and then you multiply by the sine of f of x. Now, there's another function, the tangent of x. What is the derivative of these? dy dx of this. Okay, is the secant squared times f primed. F primed times the secant squared of f. Like this. Y equals the cosecant. What is the derivative of the cosecant function? So dy dx is going to be the same as minus cosecant of f of x times the cot of f of x times f primed of f of x. Y equals the secant of f of x. Then we can get the derivative dy dx of this. What is the derivative of the secant function? Is the secant of f of x, the tangent of f of x. The derivative of the function becomes f primed of f of x, f primed of x. Right, so now we revise as well. So the derivative of the cosine is a minus sine. The derivative of the tangent is the secant squared. The derivative of the cosecant is minus cosecant the cotangent. The derivative of the secant is the secant times the tangent. The derivative of the cotangent. Right. So in other words, if you have this lesson is being recorded, so you'll get this video, this recording. Right. So y equals cotangent of f. It means, therefore, you can find the derivative of this so that dy dx of this is exactly minus cosecant squared of x f primed, like this. Okay.
Yes.
Next, let's look at some examples of this. Let's look at some examples of this. Right, so, and we're asking the question here to say find dy dx. Y equals the sine of 2x minus 3, the sine of 7x. Dy dx. Right, let's look at the derivative of this now. What is the derivative of this function? Right, the derivative of this function is clearly what? Because the derivative of the sine is the cosine. Right, the cosine of 2x.
Cosine 2x, yeah.
And then you multiply by the derivative of the sine, or of the 2x. What's the derivative of the 2x? It's 2 with respect to x.
Yeah.
Right, and then the derivative here, 3 is a number. So the derivative of the sine is again the cosine
Cosine
of 7x. The derivative of 7x is only 7.
7.
Yeah, and therefore you just, this is the answer already, but you can write it as 2 cosine 2x minus 21 cosine 7x. Okay. I want us to spend a bit more time on questions that are extremely, extremely important. Advanced questions. Advanced questions. Right, we shall spend a bit more time on advanced questions. Next question. Right, so we're looking at a little bit more at examples. Right, looking at the examples, we're looking at the first one. And what is the first one? And here is the first one. And the first question is going to be on multiple. We're going to do also integration. So determine the following integrals. Okay, we have this one. Okay, so we have 2a cubed plus 3bx squared plus 6cx plus d. Okay, we need to solve this one. We need to solve this particular question. And we need to look at what to do to solve this particular question. All right, now they asked this question to say, let's do this. And we look at the solution to this. Right, so a problem like this now requires us to look very carefully and realize that we have a square root and we have something outside the square root. So what we do here is we let u be what is under the square root.
Yes.
So u, because the derivative of what is under is going to bring what is outside. So 2a cubed 3bx squared 6cx plus d du dx. The derivative of this one with respect to x. So the derivative of this one is 0. Then derivative of this one, 2 by 3b. Derivative of this one is 6c. So now we look at these carefully. Okay, there's an x here, please.
Okay, so there's no x behind the 2a cubed.
Okay, that's a good question. Yes, there's no a beside the 2a cubed.
Okay.
Yeah, good point. But yeah, there's no x there.
Okay. All right. All right.
Okay, good. And this is exactly what we are getting here. Okay, okay, that's a good question. There is a small typo in the question. Okay.
Yes.
Yeah,
Yeah,
good.
that
Okay,
was.
good point. You noted that. Yeah, but there's a small typo here. It's ax cubed,
Yes. Yeah,
like
so it's
that.
going to be, yeah, it's going to be three
So it's
or
gonna be
six. Yeah.
exactly 6
Yeah.
here.
Yeah. 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 It's also going to
Yeah,
be
good. I'm happy that you
6a.
realized that because yeah, somebody omitted something because I'm taking it from the question paper. So so it's the derivative of these, therefore, okay, the u is gonna be 2ax cubed.
Yes. So at the bottom is going to be 6ax to the power of 2.
Yes, well done. So it's gonna be
Yes.
6ax squared
Yes.
plus 6bx plus 6c, like this.
Yes.
All right, so you continue.
Yes. And
All
isn't
right,
it
so yeah,
supposed to be
moving
the,
forward.
sorry, the oh no, 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 never mind. No, I thought that d is going to be +1, but it's not going to be +1 because it's not an x.
All right, that's
Yeah.
fine. Thank you so much for engaging with the ideas. So that we have du dx is 6ax squared
Yes.
6bx
Plus 6c.
plus 6c. And then what is the answer? Okay, so yeah, we can write this in many ways, but we can factor out,
6.
we can make dx the subject,
Yeah.
getting du over, and then we can factor out 6 from this, getting ax squared plus bx plus c. What is this? Ax squared plus bx plus c. Right, and then you have the square root of u. Right,
Yes.
and then the dx is exactly going to be du divided by 6 ax squared plus bx plus c. So this is exactly 1 out of 6, the integral of u to the 1/2 du.
Yes.
And therefore, I'm glad you're able to follow this 1 over 6 u to the 3 over 2, but you divide by the same thing, plus c. Okay, so we always, this is the law of integration. So you always divide by the same thing. So this is 1 over 6. Because you are dividing by 3 over 2, you're multiplying by the reciprocal.
Yes.
U to the 3 over 2 plus c. Okay, so 2 divides here, giving us a 9. And this here becomes, you can write it as u cubed 1/2. 1 over 9, the square root of u cubed, plus c. 1 over 9. What is u here? Is what we had.
In the
So
beginning.
u is all this.
Yes.
Right, good. So u is exactly, okay, we're gonna do a lot of problems, but this is just a start. Okay, right. So we have 2ax cubed plus 3b x squared plus 6cx plus d plus c. So this basically is the answer to the question. Okay. What is the next problem? Here is the next question. We're looking at example 2 now. Right, so in view of example 2, and it says evaluate. Ten squared of and then you have cosine squared of 2x dx. Okay, so now we need to do this one. And what is the answer to this particular question, and how can we do this question here? Obviously, a couple of ways to do this question. Right. And we can look at it and think of how we can do it best. But for example, you can be able to see that the solution can be written as follows to this question. You can write the question, the integral of this, 10 squared of 2x minus 9 dx. So you have these, then you have 2x minus 9 dx. Okay, 1 over the cosine squared is the secant squared.
Sorry, can you repeat that?
1 over the cosine squared is the
Yes. Oh,
secant
yes, yes,
squared.
yes, yes, yes. Sorry. Yes, yes.
Okay, that's fine. I'm happy that you're able to note that. All right, and now we are in a better position to use a formula. There's a formula that we use. The formula that we use is that the integral of, if the derivative of a function sits here, and you have f of x, which you square, minus a constant squared, over 2, which is arc, the hyperbolic cosine, right, the hyperbolic cosine of f of x out of a plus f of x over 2 okay, let's put a plus here, so this one is f of x plus c. Okay, this is the formula we're going to use. Hence, if you have the integral of the secant squared of the tangent squared okay, so we can see therefore that this 9 can be written as 3 squared. Can be written as 3 squared. And this is minus, according to this formula, is going to be 3 squared here, which is going to be 9 out of 2 arc cosh of the f function. The f of x function is what sits under the square, which is the tangent of 2x divided by the 3, the base, plus f of x, which is what is under the square, the tangent of 2x over 2. Let me write it at the bottom. Which is the tangent of 2x over 2 squared minus 9. Okay, so that is the answer. In other words, the integral of this here is exactly this. Right, another example. Another example on integration. Okay, let's look at these indefinite integral. The integral of the hyperbolic sine of x, 1 plus cosh dx. So we need to find this question. So what do we do here? We look at the solution to this. What is the solution to this question? Right, so the solution to this is very, very straightforward, but very easy. We note first that the integral of, there's a formula that we're going to use. And the formula is if you have f primed, f of x dx, which becomes the ln of f of x plus c. So you have 1 plus the cosh dx. So the derivative of this, in other words, this is the same as 1 plus the cosh. Then you have 1 plus the cosh of x, and you take the derivative of that, dx. And now, according to this formula, because the derivative of the cosh is the sinh, the hyperbolic sign, so that this is the natural log of the denominator. Like this. We continue. The next example. The next example. The next one is a definite integral. A definite integral, an example. Right. Find the integral from 0 to pi out of 4 of the sine cubed times the cosine cubed of x dx. What is the integral of this? What is the integral of this? Okay, very straightforward. Let's look at the solution. All right, first you need to perform some dissociation or some separation of this. So you note down this integral here of the sine cubed of x cosine cubed dx. The integral of 0 pi over 4. You can keep the sine cubed here and write here cosine squared times cosine x dx, like so. Right, and upon further examination of these, we can see this integral of the sine cubed. Cosine squared is 1 minus sine squared of x times cosine x dx, like so. The integral of these which is 1 minus sine squared x cosine x dx. Right, by distribution, this is the integral from 0 to pi over 4 sine cubed cosine x. Pi over 4, the sine, if you multiply here and right now, sine to the 5th power. Sine cubed by sine squared, sine to the 5th power, times cosine. Cosine x dx. So what is this? So here, there's a formula that you need to use here. But also, we use the formula that is very famous, that cosine squared plus sine squared is 1. Cosine squared is therefore 1 minus sine squared. Let u be sine. Let u be sine. The derivative of sine is cosine. It cancels this. And therefore, we get sine to the 4th power of x. Sine to the 4th power of x. So now, okay, I'm going to state the formula here. Over 4. So this one here, the derivative of this, the integral of this, because the derivative of the sine is the cosine. So this cancels out. And I'm going to give the formula. But this, therefore, is like you adding 1, you add 1 to 3 and divide by the same thing. Pi over 4. Six of x divided by 6. 0 to pi over 4. Look, the couple of things that we need to state here. The formula that the integral of a function to the power n whose derivative is outside. There's a function whose derivative is outside. Dx. This is the same as f of x to the nth power divided by the nth power plus c. Like so. Right, so in other words, we use that formula here because we can see that, okay, the derivative of the sine is the cosine. Because the derivative of the sine is the cosine, then we can just quickly just add 1 to 3 and divide by the same thing and take the integral performed from 0 to pi over 4, but also the same to the next term here. And we got that exactly. So what is the answer to this? So this is the same as. So this is the sine of pi over 4, do it on a clean slate. So this becomes the sine of pi over 4 to the 4th power minus the sine of 0 the sine to the 6th power of pi over 4 over 6 minus the sine to the 6th power of 0 out of 6. What is this? This is exactly the same as the sine of 0 is 0. So
Yeah.
this nullifies and becomes 0. And what are we left with exactly at this point? We're left with 1/4. The sine of pi over 4 is 1 over the square root of 2 to the 4th power. 1 over 6. 1 over the square root of 2 to the 6th power. If you raise this to the 4th power, the 1/2 is just going to become like, it's going to make this, because the square root is like 1/2. So half of 4 is 2. Same here. 1/2 and becomes a 3. Right. So this is 1/4, 1/4. 1/6, 1/8. One out of 48. And so what is this? 48. 48 divided by 16 is 3 minus 1. And what is the answer? It's 2 out of 48. 2 out of 48. So, I mean, it
1 over
means the
24.
integral from 0 to pi out of 4 of the sine cubed of x times cosine cubed is 1 out of 24.
Yeah.
Well, yes. Before that, one can say it is 2 out of 48, but 2 out of 48 is 1 out of 24. And
Yeah.
1 out of 24 is approximately 0.042, but yeah, it's enough like that.
Okay. So you don't need to write the bottom.
Yes, the decimal is not necessary.
Right?
All right, but yeah, this is recorded, so you'll have access to the full video of this, the full recording. Next example. What about if we have the integral? And here the question is evaluate the integral of dx divided by x squared plus 4x plus 20 plus 4x plus 20. Right, let's look at the solution to this. What is the answer? Okay, this is very, very easy. Right, because the integral dx of x squared plus 4x plus 20 is the integral of dx divided by so at this point, you have 4x, you complete the square. You take half the coefficient of x minus the same thing. We add 20 to this. And what is all this here? X plus half of 4 is 2. You put all these three together. Minus half of 4 is 2. You square 2, you get a 4. Plus 20. And this is the integral of dx divided by x plus 2 squared plus 16.
Hmm.
And what is this? This is exactly dx over x plus 2, 16 is 4 squared. And so there's a formula. Okay, if you have the integral f primed of x divided by f of x plus a squared, what is the answer to this? This is exactly 1 out of a. Arctan of f of x out of a plus c. With that said, hence we have the integral so the integral becomes the 4 squared here. You can write that one down here. So this is exactly 1 out of 4.
Hmm.
Arctan of f of x, which is x plus 2 divided by 4 plus c. So this is the answer to the question. Right, so there's something we call implicit differentiation and the implicit function theorem. So the next thing we're going to discuss is implicit. Right, so we're going to proceed to discuss another form of differentiation that comes in the exam called implicit differentiation. Implicit differentiation. What is the question? Find dy dx if the cosine of x squared plus y squared minus 2xy is equal to 0. Let's look at the solution to this. Let's look at the solution to this. What is the solution to this? So the solution to this is very straightforward. First things first, we write down the question. cosine of this plus y squared minus 2xy equals 0. What is the derivative of this? First, we find the derivative of cosine. The derivative of cosine is minus sine. By the chain rule, we multiply by the derivative of the argument or the interior, the inside of the function, minus the derivative of 2xy equals 0. Minus the sine of x squared plus y squared. The derivative of x squared plus y squared minus the derivative of 2xy equals 0. This is x squared plus y squared. What is the derivative of 2x of x squared? It's twice x. The derivative of y squared is twice y. By implicit differentiation, we multiply by dy dx minus. Now we come and we put an open parenthesis, and we can put the 2 outside. What is the derivative of the xy? The derivative of the x is 1.
1.
By the product rule. And then we have x. The derivative of the y is dy dx. We used the product rule here, and the right-hand side is identically 0, like so. We perform distribution. And this means we have minus 2x, the trigonometric sine of x squared plus y squared, minus 2y the sine, x squared with y squared, dy dx, 2y 2x, dy dx equals 0. Okay, so you have dy dx here. Factor out dy dx as a common factor. We're left with minus 2y x squared plus y squared, which means here you have 2y plus 2x the sine of x squared plus y squared. Dy dx. Two y plus 2x the sine of x squared plus y squared. You divide everything by this. What do we divide by? So we divide exactly by this expression. So what is this expression? So it's minus 2y sine. Minus 2y the sine of x squared plus y squared. Minus 2x. Like so. 2 is a common factor right through, meaning dy dx is y plus x, the trigonometric sine of x squared plus y squared. This is divided by, now the 2 is going to cancel out because every term has 2, meaning we have minus y, the trigonometric sine of x squared plus y squared minus x. And this is exactly the answer. But I must indicate that this answer can be written in many ways. For example, Another student can write the answer as dy dx. You allow the negative to go up. So you have minus x, the sine of x squared plus y squared, divided by y, the sine of this, plus x. Like so. And this is the answer. But this answer can also be done in three steps. In three steps. Right. There's another formula we use called the implicit. The implicit function theorem. Right. So the implicit function theorem is a very powerful theorem that we sometimes call the bulldozer theorem. Bulldozer theorem because it's as strong as an elephant. It's powerful. So we mustn't lose sight of the fact that we need to find the derivative of y with respect to x if we are given the cosine. X squared with y squared minus 2xy equals 0, like so. Okay. We are in business and we proceed with ease and want to present the solution in a slightly easier manner. Hence, we look at the solution to this problem. What is the solution to this problem? We let f of x and y be equal to this expression that is equal to 0. Cosine of x squared plus y squared minus 2xy. Upon further examination, we realize that we can use partial derivatives. So f sub x becomes the partial derivative of f with respect to x. What is the partial derivative of this? In other words, the partial derivative of the cosine is minus the sine. Minus the trigonometric sine of x squared plus y squared. But you multiply by the partial derivative of x squared plus y squared by the chain rule. Minus 2 into the partial derivative of this with respect to x, which is the derivative of x partially is 1 times y, like so. What is the meaning of this? F subscript x. The derivative of x squared is what? 2x minus twice x. The sine. Like this. Minus 2y. Like this. And the multivariable function we got, which is cosine minus that. Cosine of x squared plus y squared minus double xy is a multivariable function. It is a bivariate function. But from this bivariate function, we want to find f sub y, which is the partial derivative of f with respect to y. What is the partial derivative of the cosine? Is minus the sine of x squared plus y squared times the partial derivative of x squared together with y squared minus 2. The partial derivative of this with respect to y is x times 1. Y. F sub y. What is the answer? The derivative of this one is y. Because it's y here, it must be y there. Must be y here. Partial derivative with respect to the implicit variable y. So that the derivative of this with respect to y is 2y times this. So it's minus 2y. So it's minus twice y, the sine of x squared plus y squared. F sub x. F sub x is minus, okay, there's something else. Because now this is going to be there, but there's minus 2x for the fy. So this is minus twice x. So this one is twice x, the sine of x squared plus y squared minus twice y for the sub x. Twice y for the sub x. What does the implicit function theorem say? By the implicit function theorem, dy dx is minus fx fy, like this. So what does this mean? It means dy dx, the derivative is minus fx fy, which is minus. What is f sub x? What is it? F sub x is minus 2x, the sine, minus 2y. Minus 2x, the sine, minus 2y. What is f sub y? Minus 2y,
Minus 2y.
the sine, minus 2x. Okay, we are here. We multiply through by the negative. 2x, the sine of x squared plus y squared.
Plus 2y.
Plus 2y. Minus 2y, the sine of x squared plus y squared. Minus 2x. How different is this answer from the previous one? Let's check. 2x, 2y, 2y, 2x with negatives in the denominator. We check. Okay, we need to just to cancel 2 as a common factor because the 2 appears and the answers are identical in every respect with the yx, yx. So we proceed to do exactly that. We can see there's a common factor. So that we have dy dx. What is a common factor there? And we have exactly y, like this. We have exactly the y, and write y plus x, the sine of this divided by
negative
x plus y, the sine of this, like so. But there's the negative in the denominator, just like that. And this is the answer as obtained before. But we're not done yet because there's something we call logarithmic differentiation. Something we call logarithmic differentiation. Logarithmic differentiation. So what do we do now? What do we do now? Here is an exercise, an example. Find dy dx if y is e to the power x times x to the power sine x. So what is this? But how do we use logarithmic differentiation? In particular, what is logarithmic differentiation? What is logarithmic differentiation? We explain in detail. First things first, we must write down the question. Y is e to the power x times x, the sine of x. The ln of y, which is the ln of e to the power x, x, the sine of x. And what is this here? This is the ln of y into the ln of e to the power x plus, this is the product law for the natural logarithm. So this is x to the power the sine of x. What is next? So we have this, the ln of e to the power x plus that, plus the ln of x, the sine, plus the sine, like this. So the ln here, the ln of e is 1, leaving us with x. And then here, this is sine x. So you have the sine of x times the natural log. Next step is to differentiate both sides of the equation, like so. X, the sine of the natural log. Now, let's find this. How do we evaluate this? The derivative of the natural log is 1 over y times dy dx, like so. The derivative of the x is 1 plus. And then now we can find the derivative of the sine. Here is the product, so we use the product rule. The derivative of the sine is the cosine times the natural log times the sine. The derivative of the ln is 1 over x, like this. 1 over y dy dx, 1 plus cosine x ln x plus sine x over x. Which is y 1 plus ln x cosine x, the sine of x over x. Upon further examination and analysis, we're able to see that y, the question, is e to the power x times x to the power the sine. E to the power x times x to the power the sine into 1 plus the natural log cosine x plus the sine of x over x, like so. And this is the answer. Okay, and we have got the answer. And we are done. But there is more to differentiation than meets the eye. The next example is testament to this. Another example. In this example, we analyze further properties of derivatives of the further arc functions. So in other words, we are asking the question, find dy dx if y is exactly the same as x the sine inverse of 1 over x. Solution. Solution. Sorry. What is the answer to this here? We're going to use the product rule. Y is x times arc inverse of this. Sorry. Okay, we continue now to solve this problem, but this is a product of two functions, and we're going to use the product rule, meaning dy dx. First, we find the product of x, the derivative of x, 1. We keep the arc hyperbolic function constant, plus x times the derivative of the arc hyperbolic function. What is it? So it's 1 over x squared plus 1. Okay, the derivative of the arc using the table is always 1 over. Okay, so obviously the table is there at the back of the exam paper. Okay, so you have this. It's 1 over. So if you differentiate the arc sine, hyperbolic sine, you get this. But you multiply by the derivative of 1 over x. So we have this. So what is this here? You can write it as x over 1 over x squared plus 1. The derivative of this is minus 1 over x squared. dy dx. One over x. And then now you look at this and you attempt to simplify this. You attempt to simplify this. What is the simplified expression here? Let's analyze together. So this x is going to cancel one of them, leading to minus 1 over like this. dy dx, which is arc sine of this. So you can pull out here 1 over x squared. You can just leave it like that. 1 over x squared plus 1. It's enough. So this is the answer to this. This is the answer to this. But for a positive x, you can have x and you factor out. You factor out 1 over x squared. The square root of the x squared is gonna, for a positive x, become this. You factor out 1 over x squared. Here you have 1 and x squared. Okay, so this is arc sine of 1 over x. 1 over the square root. Like this. This is the answer. There are certain things that we need to learn. And we shall recap and expand on these, but there are certain things we call the Maclaurin series expansions. Let's discuss Taylor and Maclaurin expansions. We look at an example. In this example, we're looking at what we call the question that says find. Find the Maclaurin series expansion of sine x to 3 terms. What is the answer to this solution? We prepare the solution together to this. Find the Maclaurin expansion of sine x to 3 terms. What do we do? Straightforward and very, very easy. But first, we must write down the formula. What is the formula? Right, the Maclaurin series formula. What is this formula? It says f of x is equal to f of 0, f primed of 0, 1 factorial, plus f double primed of 0.
Sorry, there must be an x in front of the plus.
Yep. Thank you so much. You're good. 2 factorial x squared plus f, the third derivative, 3 factorial, the cube here, and so on. And it goes on to the nth derivative. You can take it to the nth derivative. At 0, you have x to the n over n factorial, and so on. So it goes on up to infinity. And obviously, we shall discuss the aspects of convergence of the Maclaurin series. Okay, let's look at some derivatives of the sine function. So we first let f of x be the trigonometric sine of x. And then what is the derivative of this? Is cosine x.
Cosine x.
What is the second derivative of this? Of the derivative of the cosine is minus
sine x.
The sine of x. Okay, let's do just a little bit more. What is the third derivative of this? Is minus cosine. Let's look at the fourth derivative. It's minus sine, and then it's going to be plus. Okay.
Yeah.
What is f of 0 from this? Is the sine of 0. What is sine 0? It's 0. If you have f primed is the cosine, so f primed of 0 is the cosine of 0. What's cosine 0?
1.
1. The double prime of 0 is minus the sine of 0. What is sine 0? 0. Triple primed. Minus cosine 0. What's cosine 0? Minus 1. The minus cosine 0 becomes minus 1. The fourth derivative at 0. So you have the sine of 0, which is 0.
0.
So, what is all this here? Well, it tells us that this is f of 0. F primed of 0x. Double primed of 0x squared over 2 factorial. Triple primed of 0x cubed over 3 factorial. And so on. Okay, let's write, we did up to the fourth derivative. So we can do the fourth derivative at 0, x to the fourth, 4 factorial. Right back to business, f of 0. What is f of 0? It is 0. No need to write. F primed is 1. 1 by x is x. F double primed is 0. This goes away. The triple primed is minus 1. Triple primed is minus 1, so it's going to become minus x cubed over 3 factorial. I must indicate that the next one is going to be x to the 5th power over 5 factorial minus, and so on, like this.
Mm.
So this is the answer. And now this is done to the third term of this. Okay. There is another question. Use your answer. Use your answer to write down the Maclaurin expansion for, okay, we want to do sine x of x. What is the Maclaurin expansion of sine x of x? Okay, so this is straightforward. Hence, if you have the sine x over x is 1 over x into, now you have the sine x, and we've already got the Maclaurin series of the trigonometric sine of x minus x cubed over 3 factorial plus x to the 5th power over 5 factorial. So divide here, you have 1 minus x squared over 3 factorial, x to the 4th over 5 factorial, and so on. So now we have found the Maclaurin series expansion of sine x over x using our answer. And this here is to the third term of this. Here's another question. Hence, use your answer to evaluate the limit of this sine x over x. What is the answer to this? We look at the solution to this. Right, so the solution to this is as follows. So we're looking at the limit as x approaches 0 of sine x over x. What is sine x over x? Is 1 minus x squared over 3 factorial. Plus x to the 4th power over 5 factorial. Okay, minus. The signs alternate here. This is minus, like so. Meaning you have the limit as x approaches 0 of the trigonometric sine of x. And obviously this is going to be 0, 0, and the limit is 1.
It's 1.
So we have that. Okay. Very, very easy. We are just, these are just warm up. We are just warming up. The next thing is we want to find the area enclosed. Here's another question. We must be able to find the area. An example on area. The area enclosed by the curve y equals x squared plus 4. The x-axis and the lines x equals 1 and x equals 4 is rotated about the y-axis. Determine the volume of the solid of revolution produced. Let's look at the solution to this. The area enclosed by the curve y equals x squared plus 4, the x-axis and the lines x equals 1 and x equals 4 is rotated about the y-axis. So we are interested in finding the volume. This is a volume question. Let us find the volume. So we must have an idea of the picture. What is the picture? Like this. All right. Like this. This x equals 1 and this x equals 4. All right. X squared plus 4. So let's find the volume here of this. Right, so there is a rotation about the y-axis. So a rotation about the y-axis is going to yield the volume 2 pi. You integrate from 1 to 4. And you have x into x squared plus 4 dx. If you rotate about the y-axis, x is between 1 and 4. And the y function is actually x squared plus 4. And you multiply it by x, and that is the formula. So that the volume, and we're yet to do volumes and areas in detail. 1 to 4. By distribution here, x by x squared is x cubed plus 4x dx. Let's integrate these here. 2 pi into x to the fourth 2x squared. 1 to 4. Volume. Minus minus so that the volume right. So obviously, if you look at this here, this is exactly 4 to the fourth power divided by 4, which is 4 cubed here. And then this one here is these two divides, giving us 4 squared, 16. And then this one is 1/4 plus 1/2, which is 3/4. This is minus 3/4. And so what you have here is 2 pi here. This is 64. 70, 80 minus 0.75, like so. And then this is exactly the same as 80 minus 0.75. 2 pi into 79.25. I'm here to discuss what we call the washer method, the disk and the washer methods separately for volumes. I'm here to discuss those methods in detail so that one can understand rotations about different regions. Rotations about different regions. Just a minute, let me just check here. Let me just check in detail what happens. Okay, I'm just checking, please. Okay, there's a small typo here.
Yeah, it's rotation about the y-axis, yes.
Yes.
Yeah.
Right. If it's rotation about the y-axis, but now the typo is there's a 4 here because it's 4. 4. Okay, there are different ways to do this, but this is surely one way. But I'm here to give details on this method of rotation. Okay, so if you divide 4 by 2, because there was a 4 there, so if you divide 4 by 2, there must be a 2 here. And then there's going to be a 2 here. And then there's going to be a 2 here. Okay, but I'm here to give more details on this method once again. And then here it's 2 and that, so which means that it's going to be 4 by 2, which is 8, 9 out of 4.
Hmm.
Okay, so, okay, but yeah, this is a different question. As said already, it requires the notion of this particular method of integration. This 2 pi volume method is perhaps not so popular, but very, very useful. Is rotation about the y-axis? Yes, but we use dependence on x. Right, so this then is the same as what? It is the 4 cubed, which is 64 plus 32 minus, which is 96. Check this. 64 plus 32 is 96. Which is 96 minus 9 divided by 4. Let me check this.
Hmm.
93.75 by 2. 187.5. That is the correct answer. So which means the volume is 187.5 pi cubic units. Okay, I'm here to spend a bit more time on this, but my point is rotation about the y-axis. But now, if we use the 2 pi method, we actually consider that x runs from 1 to 4, and the function itself is the y equals x squared plus 4. We multiply that by x and integrate.
Okay.
Okay. I'm yet to give more details on this particular method. Okay, now the next question is about a beam. Another example. A beam of length L has a uniform load W given by W equals W0, the sine of pi x over L, where W0 is a constant and x is the distance along the beam. The total load P and the reaction and the reaction R are given by P is equal to the integral from 0 to L of W dx. In which case, then, it is clear that the reaction is the integral from 0 to L of xw dx. We need to show that P is the 2W0L divided by pi. Let's do this question. Let us do this question. So we present the solution to this. But not only these, there's another one, another question that we need to show that the reaction is W0 L squared divided by pi. Okay, so these are just integration problems, applications of integration. Let's look at the solution to the load and beam problem. Right, look, there are a couple of things that remain pivotal here, but that are extremely important for us to consider. We note that W0, but first just W alone is W0, the sine of pi x over L, and P is the integral from 0 to L of W dx. So that now we can be able to find P by substitution, because W is W0. So wherever there is W, we put W0 times the sine. Substitution is W0 times the sine pi x over L. So we integrate these right now, and to integrate these is very, very straightforward. So W0 is a constant. Can pull it out. If you integrate these here, the sine, it becomes minus cosine, but you divide by the coefficient of x. So which means that it becomes L over pi inverted. It becomes the other way around. But the integral of the sine is minus the cosine by x. 0 to L. Minus, like this. Cosine, wherever there is x, you put L. So that's going to be pi L over L minus the cosine of pi 0 over L. Now the L cancels here. So you have P equals minus W0L over pi into the L cancels, giving us only cosine pi. minus. Here, the 0 makes everything 0, meaning cosine 0. W0 over pi. What is cosine pi? It's -1 minus 1. Minus 1 is what? Is -2, giving us 2 omega 0 L, or rather W0 L divided by exactly that. And this is the answer. Hence, P is required. Hence, P is required, which is the total load, is 2 W0L over pi. This here is the total load. Is the total load. Like this. Now, we move forward to do the next thing. Is to solve the next question. Showing that the reaction in this load beam question, the reaction is given by W0L squared divided by pi. Solution to this. Solution to this. Right, so the solution is as follows. The solution is that the reaction is the integral from 0 to L of xw dx. Yes. But what is this w? Is w0 the sign of pi x over L? Okay, I'm here to spend time on expanding on some of these to make sure that you understand the different parts that form these exam. Okay, right. So this is W, and you just substitute W, which is W0, the sign of pi x over L dx. Now, the next thing to do here is to try and analyze this in detail. We need to look at the specific parts that form this. What must happen now here? We're going to use integration by parts because there's x here outside and there's x inside the argument. So we're using integration by parts. Which is the integral from 0 to L, W0, the sine of pi x divided by L dx. Okay, integration by parts. Minus the integral of v du. Okay, so we let u to be x, and then we take let u to be x, and then everything else is dv, which is w0, the sine of pi x over L dx. So we differentiate this one. Du becomes dx because du dx is 1. The derivative of this is 1. We integrate this one now with respect to x. Ideally, we find the derivative of this, rather the integral of this. Right, we perform integration both sides of this. So that v, if you find the integral of these, is minus cosine. Cosine pi x over L. Okay, because if you integrate this with respect to x, then the L and the pi change places and the L goes up. You sort of divide by the coefficient of x. And you have this kind of format, but yeah, this is our v, like this. And with this said, then we are in business hands. Which is pi x. Okay, we're continuing. If this is the case, we use integration by parts. And the integration by parts says the integral of u dv is uv minus the integral of v du. So this integral here is going to be u. What is u? X. What is v? Everything here is minus w0L over pi. Minus w0L over pi. Okay, I'm yet to spend a bit more time on the volumes and areas of revolution. Okay, so cosine. Okay, I'm watching the time as well. Cosine of pi x over L. Like this. So this is like u v minus the integral of v. All this minus w0L over pi cosine pi x over L. V du, which is dx. Right. Let's continue. So what is all this here? Okay, so this here is the same as minus x W0 pi cosine of pi x over L. Okay, so negative by negative is plus. You pull out the W0 L over pi because it's a number. These, all of them are constants, and then you integrate the cosine becomes sine. But you sort of divide by this, or this L goes up and the pi comes down. You divide this by the coefficient of the x, and you have the sine of pi x over L. Like so. And so what is this here? Well, it is the reaction is given by minus x W naught L minus x W naught L divided by pi. Times cosine of pi x over L. Cosine of pi x over L. Now here, this is like pi squared, and this is L squared, so it's W0 L squared over pi squared. Right, so it's W0 L squared over pi squared, the sine of pi x over L, times the sine of pi x over L. 0 to L. All right, so which means you have minus L, W0 that, pi, the cosine, wherever there's x, you put the L, which is pi L over L. L squared over pi squared, pi L over L. Over pi, the cosine of pi is 0. Pi is 0 over that. Substituting wherever there's x, you put the 0 now. Meaning the reaction is equal to, okay, at this point, this cancels out. And this is going to give us minus L, W0 L squared over pi, and this is minus 1. So this is going to be minus W0 L squared over pi. And this is the cosine pi. Right, and then this one here is cancels out, and you have W0 L squared over pi squared. W0 L squared over pi squared, the sine of pi. And then this one here is 0. But there's also a 0. So this is going to be 0, and this is going to be 0. So this is minus 0 everything. 0. The reaction. The cosine of pi is minus 1. so that when you multiply here, it becomes W0 L squared over pi. The sign of pi is 0. So this is W0 L squared over pi. And the conclusion hence is that the reaction is L squared. You can write it like that. It's actually W0 L squared over pi. Now, this is the reaction as required in the question. And we are done solving this particular problem. And our time is sort of elapsed because what time did we start? Can you remember?
I think quarter past, wasn't it? Quarter past 7?
Yeah, well done. It was in the neighborhood of that time. So it was at about, I know I noted the time.
Oh, I can't remember now. I know I
I
joined
think
7 o'clock. I don't know what time we started
about
exactly.
7:10.
Yeah,
All right,
yeah,
was
could be,
it
yeah.
about 7:10 that we started?
Yes.
Yeah, okay. Anyhow, I know that our time is elapsed, but yeah, I normally note the time on the screen because yeah, we started at 7:10 and this was our start.
Oh, yes, yeah. Okay.
Yes, I noted it here. Okay, if that is our start, then our finish. Okay, it's just 2 hours that we must take. Our finish has to be 21:10 in 2 hours.
Hmm.
But it's okay. What I'm gonna do is I'm gonna give you a homework.
Okay, yes.
Okay, here is the homework. So because it's our first lesson, the homework is not gonna be very long. It's gonna be pretty short, but very short. And here is the homework. Okay, homework. Home activity. Okay, number one, find Okay, I'm gonna be with you now. Okay. All right. See. Okay. Find d squared y dx squared. If x is e to the t minus 1, and y is e to the t out of 2. The next exercise, if this video is recorded, so I'm going to send you this video with everything we did. Right, so if I is V over R is Ohm's law,
Yeah.
and V is 250 volts, and R is 50 ohms. Find the change in I resulting from an increase of 1 volt in V and a decrease of 0.5 ohm in R. Okay, this is the home activity. So you just have these two questions.
Thank you so
So
much.
please come again.
I said thank you so much.
All right, excellent. I'm glad that we had this discussion today. Our time has elapsed, and we just obviously normally discuss for 2 hours. You're writing on Monday. We still have ample time. We can have our discussion tomorrow,
Yes,
ideally. So
that'll be
yeah,
perfect.
but obviously it's up to you. Let me know.
Yes, yes, yes. I'd like that.